This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google Ivy Panda Free Essays.
Reflection and refraction of light. Examples. Introduction. Light can be regarded as a complex phenomenon due to the fact that it is intangible, and its uses in day-to-day life are innumerable. However, the properties and behaviors of light have been extensively studied by the use of simplified models of light constructed using wave fronts and rays. A wave front can be defined as a surface that connects light that is produced from a source simultaneously. A ray, on the other hand, is a thin beam of light that travels in a straight line. By using the stated models, the properties of light can be effectively studied. Some of these properties include the refraction of light and the reflection of light. This paper is an in-depth analysis of the facts surrounding the reflection and refraction of light. Reflection. Reflection refers to the bouncing of light off a smooth surface. An example of a common occurrence of light reflection, and that which can easily be seen, is the reflection of light off a smooth pool of water. In this case, the environment around the water can be seen in the water because the reflection on the water captures its image. If the surface of the water is perturbed, waves are formed, which scatter reflected rays and hence disrupt the reflection. The angle between the perpendicular line, the normal, and the incident ray is known as the angle of incidence or the incident angle. On the other hand, the angle between the normal and the reflected ray is called the angle of reflection. Laws of reflection. Reflection is governed by one law: the angle of incidence equals the angle of reflection. Plane mirrors and other objects whose irregularities are so small that the wavelength of light is larger. Light is reflected in only one direction. This phenomenon is termed as specular reflection. However, if a surface is so irregular that light wavelength is smaller than its irregularity, it reflects light in all directions. This phenomenon is termed as diffuse reflection. Regardless of whether light is reflected in specular reflection or diffuse reflection, the law of reflection is observed for each light ray on a microscopic scale. There is also another law of reflection that states the incident ray, the reflected ray and the perpendicular line of impact all fall on the same plane. This is mainly applied in forming geometric optics for curved surfaces like concave and convex mirrors. Applications of reflection. One of the greatest applications of reflection is the fact that we are able to see objects due to their ability to reflect light off their surfaces. The only exception to this principle is objects that are able to emit light. These are very rare. Reflection is also applied in a number of ways by the use of spherical mirrors. These are used in surveillance, in automobiles, etc. Movie screens and projectors are made possible by the phenomenon of reflection. The study of the universe is made possible by the fact that the bodies in our universe reflect some light from the sun. Refraction. All of us have at one point experienced refraction of light. When a stick, pencil, straw, and the like are immersed in water, soda, or any other transparent liquid, it is noticeable that the former bends at the exact point where it gets into the liquid. This is an effect of refraction. Refraction can thus be defined as the bending of light as it enters a denser medium from a less dense medium, or as it enters a less dense medium from a denser medium. This bending of light is due to the change in the speed at which the light travels in a certain medium due to a higher or lower refractive index. Just like in reflection, the respective angles separated by the normal are called the angle of incidence and the angle of refraction. As light moves to a medium which is less dense, it will be appropriately refracted away from the perpendicular line. The maximum incident angle possible in the denser medium, in order for the refracted ray to just emerge out into the less dense medium, is called the critical angle. Laws of refraction. The laws of refraction are as follows: the incident ray and the refracted ray lie on either side of the normal to the boundary of separation. The incident ray, the normal and the reflected ray lie on the same plane, which is called the plane of incidence. The angle of incidence is greater than the angle of refraction when light enters a denser medium from a less dense medium and vice versa. The sign of the angle of incidence bears a constant ratio to the sign of the angle of refraction for a given pair. This constant is called the refractive index of the first medium with respect to the second medium. This is what led to Snell's law, commonly used in refraction. Applications of refraction. Among the main applications of refraction is the use of refraction in the manufacture of optical lenses. These are used for correcting defects in sight like myopia and hyperopia. Refraction is also applied in ophthalmology, in which it is appropriately used to determine if an eye has a refractive error. In this case, it is also used to determine the best corrective measures for the eye. Refraction is also commonly applied in underwater acoustics and magnifying apparatus like the microscope and the telescope. There is also the common use of the ideas of refraction in the manufacture of liquid crystal display (LCD) screens. Refraction is also commonly applied in the study of colors. This is enabled by the use of prisms. Refraction is also applied in cameras and magnifying glasses. The twinkling and shimmering of stars is due to the changes in the density of the atmosphere, which make light from the stars to be refracted. There is also the phenomenon of mirage, which is also an effect of refraction. Differences between reflection and refraction. Reflection and refraction have a number of differences. One of the main differences between reflection and refraction is the fact that, while refraction can be described as the bending of light, reflection can be described as the bouncing of light. Secondly, in reflection, the incident angle is equal to reflected angle, while in refraction, the incident angle is not necessarily equal to the refracted angle. Most of the applications of reflection are based on the idea of light traveling in air and being reflected off a surface, while most applications of refraction are based on the idea of light traveling within the media refracting the light. Thus, in reflection, light travels through air, while in refraction, light travels through different media. Another difference between the two is the fact that reflection is commonly associated with mirrors, while its counterpart, refraction, is commonly associated with lenses. Another difference between reflection and refraction is the fact that in reflection, light travels in uniform speed, i.e. frequency and wavelength, while in refraction, the frequency and wavelength of light changes, and thus its speed also changes. Conclusion: light is a very important part of life. Although sometimes the study of the dynamics of light may seem to be confusing, refraction and reflection aspects of light are quite simple, and they have a myriad of applications. As evidenced in the discussion above, refraction and reflection have a number of differences that distinguish them. However, these two phenomena of light also have a number of similarities. First of all, they are applicable in all kinds of waves, including light waves. They also help to make bodies in the universe visible, since some bodies reflect light from the sun, while others twinkle due to the difference in the densities of layers of the atmosphere. This research paper on reflection and refraction of light was written and submitted by your fellow student. You are free to use it for research and reference purposes in order to write your own paper. However, you must cite it accordingly.